With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. The question says that standard enthalpy of formation of C3H7NO2, CO2 and H2O liquid are given to us respectively. Standard enthalpy combustion of CH4 at 25 degrees Celsius is also given to us. Now we have to calculate delta H for the reaction which is given to us here. So we have to calculate delta H as well as we have to calculate delta U, that is change in internal energy for the combustion of C3H7NO2. So firstly, to find out delta H, we need to know the enthalpy of formation of methane, CO2, N2, C3H7NO2 and also of H2O. Some of the enthalpy formation have been given to us. So what we are going to do, write down the reaction firstly. So the reaction is 2CH4 plus CO2 plus half N2 giving C3H7NO2 plus half H2. So this is the reaction which is given to us. Now we have to find out the enthalpy of formation of methane here, right? So for this particular reaction which is given to us, now we have been given the values. So utilizing this value, we can easily calculate the value of delta H. That is, delta H will be equal to what? Enthalpy of formation of CO2 which is given to us, because we have been given the delta H of the reaction. What we have been given here? We have been given that the standard enthalpy combustion of methane, that is CH4, is 25 degrees Celsius is minus 212.8 kcal per mole. So let me write down the enthalpy of combustion reaction of methane also. So the combustion reaction of methane will be methane reaction with the oxygen O2. What will it form? It will form CO2 as well as H2O. Balance out the reaction. So I balanced out the reaction here, and we have plus 2H2. So the delta H is given to us here. What is the delta H value? The delta H of this reaction is how much? The delta H is equal to minus 212.8. This is given to us. Now we are going to utilize this value here. So the delta H is enthalpy of formation of CO2 plus twice enthalpy of formation of water, that is, let me write that down in the bracket, H2O, minus the value of enthalpy of formation of methane, because we know the enthalpy of formation of O2 is equal to 0 because it is in its elemental state, right? And we know what is the delta H value of this reaction. This is your reaction number 1. So its enthalpy of formation is, enthalpy change is minus 212.8, which is equal to minus 94.05 plus 2 minus 68.32 minus enthalpy of formation of methane, that is CH4. So the enthalpy of formation of methane, that is CH4, is equal to how much? It is equal to minus 17.89 kcal per mole. This is the value coming out. Now we have to calculate the enthalpy of formation. So we are going to utilize, now this is your reaction number 2. Now for this, what we are going to get, we have to calculate delta H of this reaction. So delta H of reaction number 2 that we need to calculate will be equal to what? The enthalpy of formation of C3H7NO2 plus enthalpy of formation of H2 minus enthalpy of formation of, that is twice into enthalpy of formation of CH4, which we calculated, plus enthalpy of formation of CO2 plus enthalpy of formation of N2. So this value will come out to be how much? So this value is coming out to be, now going to replace the values. We have minus 133.57 minus 2 into minus 17.89 minus 68.32. Now going to solve this. The value is coming out to be how much? It is coming out to be minus 374 kcal per mole. So this is your delta H value which is coming out here. So we have found out the first part, that is the enthalpy change of the reaction, which is equal to minus 374 kcal per mole. Now the second part is to calculate delta U for combustion of C3H7NO2. So firstly I'm going to write down the reaction for the combustion of C3H7N2. So we have C3H7NO2 plus O2, writing down the balance equation. So how much it will be? 15 by 4 O2. This is the balance equation, giving 3 CO2 plus half N2 plus 7 by 2 H2. So we are going to calculate the delta H here. So we have to calculate the delta H value. So the delta H combustion, that is C, delta HC will be equal to what? 7 by 2. Going to write down all the values. 7 by 2 into enthalpy of formation of H2O plus N2 value is 0, so write down 0 directly, plus 3 into enthalpy of formation of CO2 minus the enthalpy of formation of C3H7NO2. It is coming out to be how much? This value upon solving, it is coming out to be 7 by 2 into minus 68.3. Then add the value, 3 into how much? Minus 96.05 minus what is the value of C3H7NO2? Minus 133.57. Now solve this value, we are going to get enthalpy of combustion here. So upon solving and adding and subtracting the values, I am getting delta H combustion equal to minus 387.7 kcal, but we have to calculate what? We have to calculate delta U, that is the change in internal energy. So what is the change in internal energy? We know that delta H is equal to delta U plus delta NGRT. So from here we are going to calculate delta U. Delta U will become, we have calculated delta H minus delta NGRT. So we will get here minus 387.7 minus what is the change in the number of moles of gaseous reactant minus of the product. What is the difference here? The value of delta N. Multiply the value here, we are getting minus 1 by 4 into 2. What is the gas constant? Gas constant we are using here 2 into 10 raised to the power minus 3. Multiply the temperature, 298 Kelvin, and solve this value. Upon solving this, we are getting it equal to, so when you solve this, how much we will get here? We will get it equal to minus 387, and the point value will be how much? Around 0.7 kcal per mole. So this is your delta U for the reaction. This is your answer to the question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.